Guys, attendance is on, so please put it. Okay, I am not expecting far too many people in the class. So let us just start. So basically, these lectures are already online. You can watch them whenever you have time. What I'll do is I'll just zip through the contents of the lectures, and so this will give you an idea of what these lectures have. And when you actually start having a look at the content, maybe this will be of help to you, right? So but keep in mind that we are really trying to just get an overview of the lectures right now. You will have to go through the lectures in detail later. So um, today I'll just maybe give you an overview of what these things are, and then you can uh, do whatever you want, where you can study at your own convenience. The lectures, the content, everything is already online on Google Drive as well as the YouTube channel. Okay, so let's start. I think the number is good enough to start. Okay, so um, this is basically, these are the slides for week 8, and there are 3 lectures in week 8. There are two aspects that we are covering in week 8. One is the state diagrams. This is another type of UML diagram, and the other thing is, if you remember, we have like 2 parts in each week now, right? One is the UML diagram part, and the other one is the system building skills. So the system building skills for this week are basically the networking skills. So we'll discuss about networking skills in the next lecture. But let's start with the state diagrams first. Okay. Mm, Insert pointer. Okay, so we have already had an idea of what the system designing looks like, right? And I told you that whenever you're trying to design a system, there are 2 parts. There are kind of things that you are supposed to communicate with someone who's going to build the system. So if you are the designer, these are the things that you should be able to communicate to the, let us say, developers. And these are the structural aspects of the system and the behavioral aspects of the system. So the structural aspects are more like your body, right? Your body doesn't change very often. Okay, your body's build pretty much remains the same. It takes a long amount of time to make a change to it, whereas your behavior, that can change multiple times in a very short span of time. So these are 2 different aspects of you, and one is the structural aspect, the other one is the behavioral aspect. So similarly, for a system too, we have 2 types of design details: the structural details and the behavioral details. So the class diagram that we studied in the previous week, class diagrams are a way to actually explain the structural aspect of a system. So you basically tell me that this system consists of these classes, and these classes relate to each other like this. Now the other thing that we would like to do about the system is talk about its behavior. We'll have to provide certain details of its behavioral aspects. So from that perspective, there are some UML diagrams that could be useful for you. And one of those UML diagram is the state diagram, right? So what exactly does a state diagram do? Essentially, you have so many objects that are there in when your classes are instantiated. These objects, of course, mean something. When they become operational, they actually mean something. So for example, one object might mean one customer for you. If we are talking about a banking domain application, so one object means it could be one customer, or object could be one account, or one object could be one transaction, right? So there are different types of objects in the system, and the idea of a state diagram is to show how a particular object's states change, right? So what exactly is a state? So a particular object is filled up with fields. Different fields have different values, and I say that as soon as there is even a slight change, basically a change in even one field, I say that the object has changed its state. Okay, so whatever state the object was previously, there is a change in that, right? And that change is essentially change in one or more fields. So you can understand that the possible number of states that are there for any object could be huge, right? I mean, for example, if you're talking about fields which are, for instance, integers or floats, right? The possible number of values that these fields can take itself is a huge number. And then you are talking about a Cartesian product of all the values that are possible for all the fields. So this is going to be a huge thing to figure out, right? How many states can there be? In most cases, only a subset of all these possible states are actually valid because in the domain that you are talking about, then the domain in which you are building the stuff, it might not be easy to to just represent something, right? And for example, it might not, leave aside being easy, it might not be even legal to represent any possible values of these fields. A typical example is, if you have an object that is representing a transaction, um, the first state, let us say in the first state before the transaction, there is some balance. I am calling it, let us say, old balance. And then after the transaction has occurred, let us say there is a new balance. The old balance and new balance should be related to each other in a very specific fashion, right? So the old balance must be equal to the new balance minus the transaction amount, considering that transaction amount is always positive, whatever it is. But if you are if these three fields, old balance and new balance and transaction amount, if there is a mismatch, if their sum is not as expected, then this state is an illegal state for the transaction object to be in, right? So that is the idea, that even though you might have many possible states for an object, only a handful or maybe only a smaller subset of them could be considered as valid states. Now, and then what exactly am I trying to say? That I'm trying to tell you that during the execution of the system, this object is going to change its state from one state to another. And when will that happen? Usually there will be some event, right? There will be something that happens because of which the data associated with the field of a particular object gets changed. So we call such instances as events, right? So an event occurred, and that is why there is a change in the state of the object. And this, if you want to call this change something, this is the word for that change is transition. So essentially the state of the object has seen a transition from one state to the other state. So this is how it looks like in a state diagram. There are two states, and then I put an arrow, and then I put the event, okay, the reason because of which this and this arrow represents the transition, that from state A to state B, and this event is basically the reason because this transition happened. Now sometimes you might want to actually express a little more about the event. For instance, you might say that even though this event might occur, the state of the object should only change if a particular condition is true. So for example, um, if you receive if you have an object which is representing account of a particular customer, and you receive a debit request on that account, that can only be that can only be honored if and only if the amount that is asked to be debited is smaller than the amount that is there in the account, right? If the account does not even have that much amount of money, you cannot go through with it. So the state of the object cannot be changed because of some reason, because even though the event occurred, you did receive a debit request, but because there is a condition that should have been met, since that condition is not true, you cannot go ahead with the state transition. So if you want to express these things in a state diagram, you can use what are known as guard conditions. So you put these guard conditions under inside square brackets, and you put them right next to the event. And one more thing that you might want to use is the concept of an effect. So what really happens is whenever there is a change from one state to another state of an object, what it really represents in the real world, okay, in the real world there will be some effect on your system, okay. There is an interpretation to this state transition. If you want to express that interpretation as well, you call it effect, and you can put the effect right after the event and the condition by putting a slash, something like this, that there's the event, there is the card condition, and then you put a slash and the effect. So this is basically it. In the very simplest form, this is probably what you will require. There are other things as well, but I've only covered the basics. So in a state diagram, this is what you are probably expected to do. You have you have an object who is going to make changes, okay. There will be changes in this object when the system executes, and you just want to reflect these changes in some kind of a diagram. So that is what you need, right? You probably need one last thing added to this whole diagram, and these are the initial and final states. So whenever you create an object, usually the way to do that is by calling, let us say, a constructor, and then after the object has been used, it finally gets destructed, right? So if you want to show these two states as well within your state diagrams, there are two symbols for it. This is the symbol to show to a start state, and this is the symbol to show a final state or the last state. And you can show transitions also from this state to some other state. So overall, what exactly are you going to do in a state diagram? You are going to show how the transitions happen for this for one particular object. Okay, this is not something across objects. You are only focusing everything on one single object, and you want to show how this object changes its state. Now, one issue that might come up is that the number of states that a particular object can have could be far too many to be represented in a state diagram, right? So we are talking about hundreds, maybe thousands of states, or even more. So in such cases, you decide upon yourself what states are the best to be shown in a diagram, right? Basically, many a times multiple states are just you can very easily represent them in a generic fashion, right? So you can say that this is a state with some amount, right? So for example, for an account object, you say account with some money, something like this. And then when some debit request comes, you don't have to write different states for different amounts. You can simply say amount debited, something like this, right? So essentially you will have to come up with some ways to figure out what states are you going to put in your state diagram. And of course, the other problem is that there might be far too many objects also in your system. So in such a case, you have to pick out what objects really are important for the understanding of the developers, right? So you basically define all these transitions for only those objects, and you don't do it for all the other objects. So these are some of the things that you'll have to keep in mind. And also make sure that you understand the fact that state diagrams are applicable for only one object, okay. They do not consider the transitions across objects. Okay, you'll have to add some state diagrams for it in your project. That is what the homework says. Any queries, if you have, you can ask. It's okay. You can, of course, go back and check out this lecture. So now let me go to the other part of this week. This might be slightly more interesting for you because you may actually you may have wished to know these things before, but now you can just have a brief overview of what it is. Again, these things are not really supposed to be taught to you in first year, but I thought, why not give you a good brief overview of these aspects, so that when you actually study them using in your regular curriculum, you can use these slides and maybe just have a revision before you start with the coursework. So the next thing that this week has are basically the basics associated with networking. So we'll just start from a very simple example, something that everyone has probably done. So opening up a web page in a browser window, right? So what you do is you basically type the address of the page in the address bar, and then you press enter, and then the page simply loads, right? You probably would have never really thought about what exactly goes on in the background whenever you do something like this. So the first thing you need to know is that the world of computer networks, it doesn't really understand these strings, right? The strings that you enter on the top of your address bar. So it doesn't understand what is IITL.ac.in. It doesn't understand what is google.com, for example, right? So networks actually work over numbers, similar to computers in general, right? I mean, even in the first lecture of ITP, we discussed these things, that essentially we are talking about a world which only which basically talks in the terms of zeros and ones, right? Anyhow, so these strings are not really directly understandable by the network, so you have to convert them into some kind of numbers. So there are two set of numbers which are of interest to us when it comes to computer networks. They are the IP addresses and the port numbers. And IP addresses are something that you might have already known about, right? I mean, you may have heard this term far too often, that what is your IP address, what in fact sometimes we just use the word IP, we don't even say address. So IP addresses are essentially unique identifiers of the members of a network. So when I say members, a network is some interconnected place where each member can talk to the other member, at least in theory, right? You may not be allowed to do that, but in theory you can contact someone else on the same network. So it is an interconnected mesh. Not mesh is the wrong word here, but basically somehow interconnected. And these networks could either be local networks managed by, let us say, an organization like IIITL, or they could be the internet, the worldwide network. In either case, if you want to be a part of such a network, such a computer network, you need to have a unique identifier on that network, and that unique identifier is the IP address. Now, if you want to communicate with another element on another machine, for example, on the network, not only do you need the IP address, you also need a port number. So port numbers are basically a kind of lane numbers, okay, or channel numbers, whatever you want to call them. So a particular member might be communicating with multiple members on the network simultaneously, or even with the same member, it might have multiple connections. Let us say because of multiple applications running. I might be running Facebook, and at the same time I might be running Messenger, right? So maybe it is possible that I'm connecting to the same server, but in two different fashions. So anyhow, so a port number is essentially a kind of lane number, a kind of identification for one particular connection between any two members on the network. So here, where exactly are the IP addresses and port numbers? We have not provided anything like this. So in order to figure out what the IP address is, by the way, there is a way in which this can be done by the computers. They call it DNS, domain name service. So with the help of a DNS, you can map uh, a particular string to a set of numbers, that is the IP address. If you actually do use the ping command on Linux, there is a good chance that it will show you the IP address to which you are trying to ping. But and by the way, an IP address consists of four elements like these. I think most of you already know that it's not an accurate way to describe what an IP address is. There are many ifs and buts associated with it. But for now, just assume that an IP address is essentially four small integers separated by dots. Now, this ping command is not really supposed to be a command which you use for checking up the IP of some remote location. The more appropriate command for doing this is the dig command. So the dig command actually goes to the net. It actually probes your network and comes up with some answers, right? These answers are essentially, most of the time these answers will be coming from a DNS server. So this DNS server will be able to tell you that for this particular string, this is the IP address, right? And you can use dig command on Linux terminal. This is basically the place where you need to, where you get your answers. So here the IP address that we are looking for is this one. There's also an entry for CNAME, which essentially says that IITL.ac.in is an alias for www.IITL.ac.in. Okay. So what really happens when we try to communicate from one end to another? So the first thing is that you need the communication ID, right? These IP addresses and port numbers of the other end. But as I said, because each member has to have a unique ID on the network, even the communicating side, right? The side that is trying to communicate also needs to have the IP address. So in order to figure out what is your IP address, you can use a command called IP. Okay, so you simply say IP space A, and then you should get some information about your own IP address. Usually it will be somewhere here. Your own IP address will be somewhere here, and there, if your machine has multiple IP addresses, you'll be able to see them here. Now we have only talked about IP addresses. What about the port numbers? We have not said anything about the port numbers. So one of the things with port numbers is that there are certain port numbers which are already known to everyone. It's global knowledge. Okay, and this is why you did not have to put the port number when you typed that stuff in the address bar of the browser. So if a particular website is operating over HTTPS, HTTP secure, then the port number by default is 443, and it is actually a well known port. It's not just used for HTTPS but for other communication as well. And if the website only uses HTTP, then the port number is 80. These are decided port numbers. There's really nothing that is required from your side. You only need to provide a port number if the web server that you are trying to connect to does not run on either of these two port numbers. And so this port number is something that is on the server side as in the side that you are trying to connect to. But on your side also there will be some port numbers which are set aside in order for this communication to go through. We'll have a look at what sockets are. But if you want to see what how many connections do you have open for against a particular IP address, you can see that using the netstat -ntp command. You can also do a grep to figure out what IP addresses are you interested in, something like this. So now till now the only things that I told you was about how do those strings get converted into integers, right? But there's far more to it than just conversion of string into integers. It is also a very hard task to send data from, let us say, a sender, let us say from your laptop to your friend's laptop over a highly unreliable medium, right? So physical mediums, air and even wires, they're actually highly unreliable. So there is a chance that you might send the data, but the data might not be received at the other end. Something happens. Okay, there is some corruption, for example, that happens in the data. So whatever you sent, it is no longer the same. So there's a lot of processing that goes on in the background whenever networks work. Okay, so in order to make this processing slightly more systematic, we use something known as the OSI reference model. So this actually involves breaking down all the computation that is required to send some message from sender to the receiver into multiple layers. Okay, and each layer is given a particular responsibility, and they get data from a layer adjacent to them, process it in some fashion, and then pass it on to the next layer. So this is, and there are a total of 7 such layers that the OSI reference model defines. So different layers, what they really do is they add or remove some information from the actual data that you want to send. So when you are sending the data, more and more information is added to the actual data packet. Okay, so the data packet keeps on becoming fatter and fatter, right? Whereas when it reaches the receiver side, at each step it gets thinner and thinner, right? So at each layer, the layer which was supposed to give it some information on the other side, that information, right, is taken out by this layer, and then it sends a slightly thinner data packet to the next layer. So to understand how it works, this is what it is. The data, here you said I want to send this data to the receiver. So then the data keeps on flowing down in this OSI reference model, and at each layer something gets added to the data packet. Then it is sent over a communication channel, and then at the receiver end the exact opposite occurs, right? So at each level, the additional package, the additional data that was added by the respective layers, it is removed, and what really reaches the receiver is the final data that you wanted to send. This is another pictorial view of how does this work. So you only had data in the beginning, then each layer on the sender side keeps on adding more and more data to it, and then finally, this is basically what happens, right? You get a very fat data packet. This then gets transmitted over the medium, and then at the receiver end the exact opposite happens, right? So the layer 1 removes its data, then the layer 2 removes its data, so on and so forth. They keep on removing data unless you reach back at layer 7, and this is basically what you want, right? You wanted to send a message from the sender to receiver. So this is what happens. Now, there are many layers, by the way, in the OSI reference model, but there are only two layers that you should probably know about at this particular point of time. These two layers are the transport and the network layer. So the transport layer is layer 4. By the way, we start counting from bottom. Okay, so the bottommost layer is layer 1, and the topmost layer, application layer, is the layer 7. So I am talking about layer 4, somewhere in between, right? So layer 4 and layer 3, these are the actual layers which probably for which you probably need to know more about. But uh, all the other layers as of now, you probably don't need to know at all. And these two layers, what exactly do they do? The transport layer is supposed to be the layer which manages the connections. So once a connection has been established between any two members on a network, it is the transport layer that makes sure that this connection is live and active. It also makes sure that whenever data is too big to be sent, it gets broken down into chunks, so when it reaches the receiver they are not out of order. So all those things are the responsibility of the transport layer. It manages the socket, by the way. And the layer 3 or network layer is the layer that is more worried about how the data actually travels from the sender to the receiver. So what are the number of hops, for example? How many places will the data bounce before it finally reaches the sender? So all those details are managed by the network layer. So if you know these two layers for now, that is enough. With just an IP address and a port number, using your own programming skills, you can communicate between any two machines over a network. So I know there might not be too many queries here, but still, any questions? So now you have a basic idea of how networking works. I know it's probably too early to push you guys there, but please go through these lectures. Um, these are all the things that you are supposed to study in future. But if you know them, and at least even if you have an overview of these concepts beforehand, it will be much easier for you when you do the actual course. So if you find time, please go through these lectures. Any questions? Okay. So the next part is essentially the coding part. So I'm going to show you how to actually write some code which can do communication between two entities on a network. Okay, 8.3. 8.3. Someone's mic is on. Okay, thank you. Okay, so let me just check if my VM is on. Yeah, it is getting on. Okay, so in the previous week, we saw POSIX threads, right? So I showed you how threads can be created using the POSIX standards. Similar to threads, there are also POSIX sockets. So what exactly are sockets? So a socket is essentially it is the communication endpoint. Okay, whenever you have a communication between two machines on a system, on a network, a socket represents one end of this connection. Okay, so basically, if you have, yeah, you should at least have two sockets in any network application, because there will be at least two parties that are communicating with each other. So there has to be at least two sockets on either side. A socket is identified by these four elements: the local IP address, the local port number, the remote IP address to which this particular socket is going to talk to. So the remote IP address and the remote port number. These are the things that constitute a particular socket. So if any of these things change, I say that this is actually a different socket, right? So for example, if the IP address is same but the port number is different, I say it is a different connection. Okay, it might be between the same two machines, as I showed to you in that netstat example. So we actually, I think it showed two communications with two connections with the IIITL.ac.in site. So the same way it is here, that if the port number changes, it is considered as a new connection, even if everything else is same, even if you are having the same IP addresses, it is still counted as a different socket. So, one of the major reasons why we are trying to study networking at this point of time is so that you actually get an overview of the scene. Okay, I do not expect that you guys are going to write sophisticated sockets and network applications, but this is basically the key takeaway from this lecture, that you should be able to understand the overall scene, even if you are not able to create that same scene using your own code. So overall, whenever you are going to have network communication, there has to be at least two entities. Okay, so if we are talking about programs, there will be at least two programs. Okay, what are these two programs? One is the server, and the other one is the client. Now here, server doesn't really mean those big expensive things that are put in data centers. A server process is basically a process which is supposed to be online all the time, looking for any clients to serve. Whereas a client process is basically a process that only needs to come online when it requires it. It can talk to the server, and then it can go back offline again. So there are two types of processes involved in network communication: servers and clients. And that is why I said that you cannot actually do any kind of communication without having these two types of entities in the system. So for any kind of communication setup, you need to know that the server must be running before you attempt to run the client. So a typical networking flow looks something like this. At the server end, and by the way, when I say server and client, it means that they could be on two different machines altogether, and they just have to be connected with each other via some kind of a network. If that is possible, then a client and a server, that it doesn't really matter much also. But let us just try to go through the flow once. So on the server side, you start listening for new connections. on a pre-decided port number. Let us call it P. On the client end, you need to say, I want to connect to a server whose IP is this on this particular port number. So for the client side, you need two pieces of information. You need the IP address of the server to which you want to make a connection to, and you also need to know the pre-decided port number, because it is on this port number that the server is listening. Once this connection request goes to the server accepts the request. From then you actually get two sockets. Okay, let us call them S server and S client. So you have now have two sockets available, and these sockets can send messages to each other or receive messages from each other. But again, keep in mind that this starting of the server must be done before starting of the client. And once you reach here at this stage, when you are just sending and receiving data, at that time it doesn't matter who was the server and who was the client. But in the beginning, one party has to assume the role of being a server, while the other party can become the client. Now, if you want to use the POSIX library for creating sockets, one of the major the pro here is that the library will create a socket descriptor for you, which is very similar to the file descriptors that you might have used in C. So that is why it is easy. It is allowed to write and read stuff over a particular socket, because the descriptor argument can also be a socket descriptor. But unlike the thread library, where it was relatively easier to tell you what functions and what header files to use, with sockets, the things are far more complicated. And this is why what I have done is I have created two utility classes for you. You can use these classes in your own projects also. If you want to use networking in your projects, you can use these two classes. And these two classes basically put together all the required infrastructure that is necessary for you to do any kind of networking. And if you still want to know more, this is just a very brief overview of the functions that are used in the code of those classes. The first step on the server side is to create a socket. So this is basically an empty socket. It is not really bound to um, any particular port number as yet. So the next step you do is bind it to a port number. You say that this socket is supposed to be listening connections at this particular port number. Then you mark it as a listening socket. So a listening socket is more like a passive socket, which has to be kept alive, but which is not really currently communicating with anyone. It's just in some kind of a listening mode. Then there is this accept method, which essentially is a blocking call. Blocking as in when you'll call it, your control will get blocked, and it will wait for a client connection. So it will remain in the blocked state as long as no client is contacting it. Once the connection has been established, once the sockets have been created, then there are methods like send and receive to send and receive data over a socket. And finally you call the close method to close the created sockets. Now at the client end, things are slightly simpler. You do not need to bind something to a port or flag it as a listening port, so on and so forth. Those things you are not required to do. What you really do is you just create an empty socket, then you ask for a connection from the server. If the connection goes through, then again you too can send and receive data using the send and receive methods, the functions. Okay, and then at the end you just close the socket. So these utility classes that I have created for you, there are two utility classes, socket class and the server socket class. The socket class essentially represents the end point of the communication at the client end, and server socket depicts the same at the server end. And once the connection has gone through, you can use methods like send message and receive message. It's a very simple scenario. The classes can only send messages uh, from the client to the server and vice versa, and that too the messages can be at max 1023 characters. But you can certainly modify the code and make a much better class for yourself as well. But for now I'm just going to show you some of the things that I have, that these classes have. Okay, any questions you can ask? Yes, so port is essentially a kind of, let me give you a simple idea that when you want to when you want to reserve a ticket, and let us say you are that old school person who does that by going to the railway station or that reservation counter, right? So there are different reservation counters probably in your city, right? There might be one that is right next to you, there might be one at the next railway station. I think almost all railway stations these days at least have a reservation counter. All the decently big railway stations have a reservation counter. So the name of the reservation counter is in some ways the IP address, right? So you basically go to that particular reservation counter, and then there are these windows over there, right? And on each window there will be one operator probably sitting or sleeping, whatever is the case. With railway employees it could be either of the two, you don't know. But on each window there will be a person who's supposed to serve the people that are standing in the line. So on that counter there might be 4, 5, or even 10, 20 different windows. So these ports are essentially equivalent to those windows, right? So these are like individual connections. Each port represents an individual connection. Now, the combination of an IP address and a port is basically what is a connection. But assuming that the IP is implicit, so then in that case, it is the port that helps the network traffic to be easily bifurcated. For example, if I am having multiple connections to the same IP address, okay, two machines are having multiple connections between them. Let us say for different applications, one is for sending Facebook data, another one is, let us say, for sending messenger data. I'm just taking an example. So in that case you are going to have two different connections between two machines, and but what will be different is the port number. The IP addresses are the same, local IP address as well as remote IP address, but what changes is the port number. Any more details? Any more questions? Okay, so the idea is whenever you are trying to do networking, the two things that you want to know are the IP address and the port numbers. These are the two things. The port numbers can be implicit. For example, if you are communicating with a website, the port numbers are implicitly known, 80 or 443. But if you are communicating via, let us say, programs, then the port numbers has to be mentioned. Okay, so let us just have a look at some example of how you can connect two machines using some C++ code. Let me share my virtual machine. Mm, I hope you guys can see my VM. So now I'm going to open two terminals here. Okay, this is the difference. Why I need two terminals? Because for a communication to take place, there has to be at least two parties. There has to be at least you know uh, two communicating members. So let me keep them side by side like this. Okay, let me put it here. So now the first thing that I have done here is that I have used exception handling. Okay, so this is something that I have told you guys to have a look at, but I did probably not give you a very detailed example. So here is the example of exception handling, by the way. Let me just. So there is a C++ standard class called exception. So I'm just extending this here. In fact, let me show you the header file first. So I'm just extending that exception class here to create another type called socket exception. And then how do I use it? You'll see this is the advantage of exception handling. uh, Server test whatever thing, because in networks there are so many things that can go wrong. Okay, at if almost at each stage there is a possibility that an error might occur. So I have put this whole code within a try block, and then I'm just catching this exception here. Right now, how is this going to benefit me? Let me show you. I open socket server socket class. Here everywhere I'm doing this throw. Okay, so at each point there might be a possibility of an error. I cannot create the socket. The binding failed, the listening failed. Okay, there are so many ways in which things can fail. Right, the accepting of a connection can fail. There are so many places where failures can occur. So now all I'm doing is I'm just doing a throw the socket exception with this message, and I'm just catching them at one particular place like this. So this is an example of exception handling as well. Whenever you need to do exception handling, this is a good way to do it, that you keep on throwing the exception, and then you have, let us say, a centralized place where these exceptions are caught. Here I've just used socket exception. You can of course have one more. You can even do further. Further you can use further inheritance to create more exception classes, like bind failed exception, listen failed exception, send failed exception. So you can create different types, and then you can put different catch blocks here. This is the way to handle these kind of errors. So anyhow, so I have a class server socket, and the only thing I need to provide here is just the port number. This is the port number where my server starts listening. It expects a client to connect to it on this particular port number. So I already have the server created. You can, in fact, let me just do it anyhow. So I have this sample server. You can see that this server is kind of stuck, right? I mean, nothing has happened. The program hasn't completed, and there is no output as well. Why? Because this server is waiting for a client to connect to it. And so now let us have a look at some the client side of the code. This is the client class, and here again I'm doing so many throw things. Okay, and here it is trying to connect to that server. Okay, and the class, the code where I'm just, I think it is called client test. Yeah. So again, the same thing is here. I put it inside try block, and here I need to provide two pieces of information: the IP address and the port number. Right? In the other case, in the server case, the server knows its own IP, so you don't need to provide the IP. But when you are trying to connect a client to a server, you must tell me where exactly does your server lie, right? So you first tell me the IP address, and then you have to tell me at what port is your server trying to listen for a connection. So I provide two pieces of information here, and then I try to connect. So as soon as this connect to server thing happens, now let me do it like this. As soon as I try to connect with the server, this is what happened, right? The connection went through, and this server received a message from client, hi from client, and the client received a message from the server, hello from server. Okay, so this is the only thing that I want you guys to understand, the overall philosophy of networking. That is the only thing I expect you guys to know, that there is a server, there is a client. The only difference between the server and the client is that who initiates. Okay, the initiation is done by the client, whereas the server is basically always ready to accept connections. That is the only difference. But once the connection has been established, after that you don't need to worry, right? In server can send a message, client can receive it, client can send a message, and server can receive it. but you need two different entities. The server code, for example, could have been sitting on some other machine as well. It would have worked. The only thing I would have that would have changed is the IP address. In fact, let me show you that the IP address that I put here is 127.0.0.1. So this is a special IP address which basically says on the same machine. Okay, it is also known as local host. A common term for this is local host. So this IP address means that my server is also sitting on the same machine as I am. But if the server program is taken away and put on some other machine, the only thing that you'll have to change is this. You only have to go and change the IP, and then everything else works. Okay, any questions?
Sir, the exception thing that you did,
Hmm.
uh, that was basically you were creating error codes for yourself.
Yes.
Okay.
Yeah. So essentially, the only thing that I'm doing here is wherever there is a problem, I have decided to handle it at one centralized location. So the throw simply means something has happened. Let us go to the error handler, and the error handler is defined within the main. So within the main, you can catch all types of exceptions. This is a very crude way of exception handling. Ideally, what people do, and this is the philosophy that is followed in Java, is that you have different types of exception classes, and they can handle different types of exceptions. Okay, so you provide more than one catch block there. Okay, so different, so you can provide different exception handlers for different types of problems. Here I just wanted to show an error message, so that is why I have just put one catch block. Any other queries? But exception handling is a very important aspect. These are all good development practices that I want you guys to learn. Okay, these things will make your job easier whenever you go to an industry, to some industry, and you are supposed to maintain your own code. A code that has exception handling is much easier to handle than code where your error handling code is distributed across the code. Okay, any questions, any queries? Okay guys, thank you. Bye. And by the way, okay, so sorry, one more thing. Your the IT section does not have a class tomorrow, but I want to take a class. Can you guys suggest some time in the evening? Um, Anyone can just collect, because I will not take the class on Thursday. Then I'll take up a class tomorrow. So then Thursday is free. So can someone tell me a time? You guys, can someone can take a survey and tell me? Anyone? Just float a survey, and please tell me the results. I want to take a class in the evening. So who's going to float the survey?
So from what time can you like give a range?
Any time in the evening I am free, no problems. You guys can pick a slot. Maybe starting from 4 p.m. onwards up to 8 p.m. I am free. Okay. So
Okay.
4 hours. Anytime in that slot is fine for me. Just tell me when I can take the class.
Okay, sir.
Okay. So Mohit, you will tell me the results.
Yes, sir.
Okay.
Yeah.
Okay. Thank you, Mohit. Okay. Bye, guys.